Daniel is here, and welcome to another episode of the Data Science TLDR, where we take long papers and make them short and concise. So today we are looking at a paper that really excites me, titled MLE-bench, Evaluating Machine Learning Agents on Machine Learning Engineering. Okay, so I am a machine learning engineer and a data scientist, and I was immediately drawn to this paper because it addresses the questions we're all wondering about. How close are we to AI systems that can actually do our jobs? While we've all experienced using, GitHub Copilot, ChatGPT, or Cursor AI for coding tasks, MLE-bench asks a much broader question about end-to-end machine learning engineering capabilities. Okay, so you can see here the guys are from OpenAI, published this paper like a week ago. So let's see what they have for us. So if I look at the abstract, they say that they're introducing an MLE bench, a benchmark for measuring how well AI agents perform at machine learning engineering. They have curated 75 ML engineering competitions from Kaggle, creating a diverse set of challenging tasks that test real-world machine learning engineering skills like training models, preparing datasets, and running experiments. They establish a human baseline using Kaggle's public leaderboards and evaluate several frontier language models. So their best performing setup, the OpenAI's O1 preview, with AIDE scaffolding, achieves at least a Kaggle bronze medal in 60%, almost 70% of competitions. You can see it here. They also investigate various forms of resource scaling and contamination effect. So let's talk about what really was tested here. So if we scroll down, they have evaluated 4 models, but first at figure 1, you can see how the MLE-bench is built. So they have all the competitions here, and various agents can interact with them. And also there's a grader that gives a grade, and they have outsourced, like open source, sorry, all of those benchmarks at the GitHub. And if we go here, they describe it, and they have 4 different models that they evaluated. And one is OpenAI's O1 preview, with GPT-4, Anthropic's Claude 3.5 Sonnet, but not the one that was published like 2 weeks ago, the one from half a year ago, and Meta's Llama 3.1, 405 billion parameters. So again, there's 4 models. We're going to see soon in the results. And a minor point, what do they mean by scaffolding? So they're referring to a framework that structures how the language model approaches the ML task, right? So think of it as a difference between just having a powerful model like an LLM versus having a model with a systematic approach to breaking down and solving problems. And they've also looked at 3 different scaffolding techniques: AIDE, which is specifically designed for Kaggle competitions; MLab's Research Agent, which is meant for general ML experimentation; and OpenHands, which is a broader coding framework. This is crucial because we know that having powerful tool is only part of the solution. You need to structure your approach to how to solve it, right? All of those frameworks are open source, and there's GitHub repos for them. So if you look at this figure, it's figure number 2. It shows the trajectories from 3 different agents doing Kaggle competitions. And what's interesting here is how different approaches tackle the same problem. The MLab and OpenHands agent operate like a general purpose problem solvers, but while AIDE is specifically designed for Kaggle competition. And as someone who participated in a few of those, you recognize the patterns, the iterative debugging, the model refinement, and checking. You can see here they talk about changing the loss function, like the LLM itself iterates. So this is really cool. And those are quite interesting approaches. Let's see the results itself. So we need to go a little bit lower to table number 2. Let's see. Here it is. And you can see, hope you're familiar with the metric. So there's submissions, and there's the models, 4 models. And those 4 are under scaffolding IAD. Those are MLab and OpenHands. And you can see how many of those made the submissions. And O1 preview succeeded in submitting something valid. Sorry, just submitting 98% of the competition. 82 were valid. But the Claude here is the Claude like half a year ago. So it's not the best Claude that we have now. So I wonder how it would perform. And you can see the results above medium is they compare to all human submissions. So O1 preview scores above medium like third of the times. And a gold medal, it gets around 10%, or any medal is around 17%. So this is quite, I won't say surprising, but it is promising. And also they looked at doing more iterations. So if we go to figure number 3, so number of attempts, they say how many times it takes until you pass the challenge, the Kaggle challenge. And you can see as the number of attempts grow, you get better results. But again, it's at least one. So you do 10 attempts, at least one of them passes, right? So it shows that there is some scaling to trying longer, but not really. And also they say here that what is interesting is that giving agents also more time, not just attempts, running longer, it does improve the performance, but still they struggle, the models, to similar challenges that we struggle, right? It's not just about having more compute, it's about making better strategic decisions. So just to summarize, for us, the practitioners, it does provide a concrete way to tackle those AI systems and how they automate our work. Maybe you can say that the 16.9 rate of getting a medal is not so threatening to our jobs, but it is a rapid improvement rate. And they have open source those benchmarks, so anyone can try and play with them now. I'm particularly interested in hearing your thoughts on this, right? So what do you think about the future? I'm using more coding assistants, and they do improve my work, but this is like end-to-end machine learning data science. So that's something we should be thinking about, and I'll be covering those topics more in the future. See you next time.